the group that has the advantage. So group 1, Ezra and Andy, for
Okay, sir.
presenting your short presentation about the paper that you have just read. So please start the video and you may start to present. You have about 5 minutes.
Wait, sir. Okay. Um. So good morning, Pak Dedi and friends. For today, um, I am partnered with Ezra, and we're going to give a presentation about force sensing resistor and evaluation of technology for wearable body pressure sensing by David Gaiofanelli and Elisabetta Varela, posted on 21st February 2016.
Yeah.
So
What
for
is the
the
journal name? Yeah.
oh, that's the journal name. The
So Hindawi is the publisher. What is the journal name?
force sensing.
That is the paper title. What about
Oh,
the journal name? Can you check, Ezra?
Um, yeah, wait a minute. The journal name. Wait. Gimana cara? How can we know the journal name, sir? I thought it was Hindawi.
Yeah, go to the link. Share the page. Share screen the.
This is the link. I share it
Yeah,
in the
yeah, yeah.
chat.
Go to the link and then share that page of the journal. Yeah, see what is the journal name? There is here. Go above, go above. Yeah, wait. This is the
Journal
journal.
of Sensors.
Yeah. So you have to put all the year, the article ID. Yeah. If there is maybe what volume, what issue, you have to put also complete, yeah, the citation data. Okay, Journal of Sensors in this
oh,
case.
here.
Okay, sir. Thank you so
Okay,
much.
it's not Hindawi is the publisher.
Okay.
If you are confused, you can download the citation here on the right part, on the right side. Download citation. You will have the complete citation list. If you download it and you open that, how to cite it, you will be there. Okay, here the abstract journal of sensor. This one is the ISBN. This one is the DOI. Okay, go back to the previous page. Yeah. So here, this is also the complete citation. Wait. Don't move. Here, right? volume 2016 article ID like this. So it doesn't, since this is an online only journal, it doesn't have volume and issue number. It just, but you need to put this also, the volume, the article ID, the pages number, the year, okay, and the DOI.
Okay, sir.
Okay, please continue with your presentation.
Okay, so let's move on. For the requirements,
And Andy, so I want to explain about a little bit about the paper. So the aims of this paper is to make a wearable body pressure sensing. So from the like the sensor, pressure sensors to become wearable. So these are the requirements. Continue, Andy.
okay, so it should involve a variation of an electrical property. It has to be low cost, uh, and sensor generating a charge displacement and use barometrics MEMS.
Why do but before I continue, why do we use what do they use barometrics maps is because it can be used to sense an interface pressure if they are drowned in some soft or liquid material such as silicones. So they also use strain gates. Why? Because it can build on flexible substrates, and for that reason, they can be adapted to the wearables for wearables. And then next, me. Next on oh yeah. So the piezoelectric, they also use piezoelectric sensors that can be found in the flexible thin film. For example, is polyphenylidene fluoride (PDF). Therefore, they try to make to combine the piezo and to make it wearable. Next. Hello, Andy.
Hello, Andy. Are you there?
I think.
I think he's frozen.
Oh wow. Hello, Andy.
Sorry sir, first metnya error.
Yeah. Sometimes it goes.
Okay. Where was it? Here, isn't it?
Yeah, udah next.
Okay, so for the working principle, it's the strain gauge. They rely on the change of resistance of a deformed conductor for quantum tunneling. When a pressure is applied, the distance between conductive particles inside the compositive changes, varying the overall material conductivity. For the percolation, uh, it has to be cheap and easy material availability. For piezoresistivity, this is the generic term used to describe the property of a material to change its conductivity with respect to the applied pressure.
So what does Andy means is that actually there are four working principles of sensors, these fours, but this paper choose the porcellation um, to because the working principle is like Andy said is extremely low cost and also available materials. Um, because of that, so they choose the third working principle. So that's all from us. Later we will try to add it more
Okay,
information.
is that all? Yeah? So
Yes,
no,
sir.
no explanation about the secondary transducer, how is it applied in the body, etc. No figures,
No, sir. Belum selesai baca, sir.
no explanation about how is it being converted into voltage change, maybe.
Uh, Actually, there are explanation about that, but um, we still not read it yet
Yeah.
because
Okay. So
yeah.
consider that this is a training for you to read fast, yeah, in the journal, and then to be able to summarize within very quick time. Okay. Thank
Okay,
you,
sir.
group. Uh,
Sorry, sir.
one, not that
Yes.
satisfying, but okay lah. Other than so let's go to group two, Grace. Yeah. For now alone, but later for the report you may get help from Angeli as well.
Oke, so ini gimana cara? Oke, so I will be good afternoon, Pak Didi, Ezra, and Andi. So today I will be presenting a paper about carbon nanotube-based thin film resistive sensor for point of care screening of tuberculosis. So when I read this paper, actually there are no explanation, or I haven't read it, but what I have seen is that there is no no detailed explanation about how the resistors work, or yeah, something like that. It focused more on the results. So okay, I'll just present what I've got. I took the paper from the Journal of Biomedical Microdevices, volume 22, number 3.
Yeah, the page numbers also should have been written, yeah, Grace.
Okay.
From which page until what page? The thing, yeah.
Actually, I cite this from Sci-Hub. This is the DOI and this is the authors. It was published in 2020. So there have been many devices, many ways, many methods that is used to detect tuberculosis, which includes the Chill-Nielsen method or the PCR. But these researchers they aim to find a device which is more efficient to detect the disease. So they use this kind of device where there are silver electrodes printed on PET film. Oh, and there are also single wall carbon nanotubes, which is bound to the antibodies, which is called the polyclonal IgY antibodies, if I'm not mistaken. And then the when the target or the bacteria or the antigen are attached to the antibodies, there will be a resistant change. That's what I got from the paper. So this is the procedure. First, tongue swab for the sample. It is then eluted, and then the first resistance is measured before the incubation, and then it was left under incubation for 10 minutes, and then it is rinsed with the ionized water, and then the resistance is then measured again. So I think maybe there is a pressure change or something like that that could change the resistance before and after the incubation, because of the binding of the target and the antibody. So here I also got some results. This is the antibody concentrations versus the resistance change. So first, when the device when the antibody is and the and the carbon nanotube wall is bound together, there is a resistance change, an increase in resistance change. But then after the antibody is after it is already bound, that is resistance change too, but it is decreasing. This is because of the hydrogen desorption. I actually don't know what it is because I haven't read in detail. And then this is the a graph which plot the resistance change when it is incubated in different temperature. This is for the MTB, the bacteria, and oh yeah, both is for the bacteria with different temperatures. This is at 25 and this is at 35. And this one, this graph here shows the resistance change when the researchers try to measure the sensitivity, if I'm not mistaken. Yeah, this is at the MTB concentrations, which means it is the bacteria, and this is the antigen, the MPT64. So it has a decreasing resistance when in increasing concentrations. I think that's all I got
Yeah.
from the paper.
Any conclusion? No, no conclusion.
Um, um, yeah, the binding of antibody and the antigen or the bacteria cause the resistance change. That's what I have gotten from what I've read. But for the detail, I haven't read that much, so I still don't know the mechanism.
Okay, so we don't know how the antibody binds to the carbon nanotube.
Oh, yeah, they directly binds here at this site
Yeah,
on top of the
by
protein.
covalently binding, or is it by physical binding, or what? What types of
Uh,
binding?
I haven't read about
Yeah,
that.
okay. Please read it further, yeah. But yeah, to be honest, this is better than the previous group. So because the graph, yeah, group one, please pay attention here. I think group two has better presentation. So at least results are also given, and principles are also clearly explained. Okay, thank you, Grace, and please all of you to what do you call it, to uh, revise your PowerPoint, yeah, and make a short report as I have put into the Google Classroom, yeah, 2-page short reports about the paper that you have read, the principle of the paper that you have read. Are there any questions?
Sir,
Yes.
as far as I have read, and that paper doesn't elaborate much more on the like the transducer or how the resistor work. Itu kayak lebih nekenin ke hasilnya. Is it okay or should I look for another paper?
Yeah, you may look at another paper. Maybe it cites some other papers. No, no, you still focus on this paper, but you can cite other papers that explain that phenomena. Usually, then
I mean,
the paper may cite other papers in its reference list. Maybe you can dig
okay,
deeper into how the mechanism works. Why that upon binding of the antigen, yeah, into the antibody, the resistance change.
okay.
Okay.
Sir, can there be a change in topic or should I and Anjali use this topic?
Use this topic, but dig further deeper into the mechanism by reading other reference paper. Understood?
Okay,
So using the same paper, this as the main paper, but you find some other paper that may explain that phenomena, how the
okay,
resistance changes upon binding.
okay, sir.